Welcome to the Basics of Graph Theory, a series of videos intended to teach you the basics of graphs. Not the kind with functions that you've been learning about since 6th grade or whatever, but the ones that look more like this, the kind that, unless you've taken college math, you probably haven't seen yet. So what are graphs? Well, it all started in 1735 when the Swiss mathematician Leonhard Euler started working on a problem. And yes, it's pronounced Euler, don't ask me why. The problem asked if someone wanted to take a walk through the city of Königsberg, would they be able to cross each of the 7 bridges once and only once? If you want to try out the problem, pause the video right now and have at it. Just don't spend too much time on it, as it doesn't matter that much. Okay, so this might be a little disappointing. There is no possible path, but Euler demonstrated this in a very important way. First, he redrew the map in its simplest form. Since the path over land doesn't change anything, each island can be condensed to a dot, and each bridge can be represented by a line. This was essentially the first graph. We now call points vertices and lines edges, and we use them to represent many other things. Back to Euler, the second thing he did was to look at the number of edges going into each vertex, what we now call the degree of a vertex. He reasoned that for any problem asking for a path going through each edge only once, each vertex must have an even degree except for the starting and ending vertices. If we look at a few other examples, we can see why this makes sense. Okay, these are a couple examples of graphs that would fit Euler's description. So basically, if these were the graphs of Königsberg, the answer to the question would have been yes. So the first thing you have to look at is the degree. So if it fits Euler's description. So we can look here, the degree of this vertex is 1, there's one edge going into it. The degree of this vertex is 2, there's 2. And the same with both of these. Okay, so this fits the description because the starting and ending vertices are odd, but all the rest are even. And it would make sense that if these were islands, you could go from island 1 to island 2 to island 3 to island 4, and you would pass each bridge once. Now in this example, it's quite a bit different. So each vertice has 1, 2, 3, 4 edges. So they each have a degree of 4. Now this already fits Euler's description. It's the different case where all vertices are even. And how this works is if you were to follow the path, you would go across this, across this, across this, and then you would have a choice which way you would go around this inner triangle. Because basically each time you go to a vertex and the degree is even, you go in and come out however many times the number is divided by 2. So for this, we can just go like that, and there, it works. So since Euler brought attention to this type of graph, many more applications and types of graphs have been discovered. Especially with the growth of computer science, graph theory continues to expand as a field. Now I'd like to show you some of the important distinctions about graphs and different divisions and how they're grouped. The most basic way to divide graphs is if they're directional or not. A graph is undirected if the relationship you're describing always goes both ways. Like if person A is friends with person B on Facebook, person B has to be friends with person A on Facebook. A directed graph could represent things like one-way streets where a connection doesn't necessarily mean you can travel both ways, and we show this with arrows. Other important labels include connected graphs, where, surprise, surprise, all parts of a graph are connected, because technically this whole thing could be considered one graph, just an unconnected one. And one last thing to note, it doesn't matter how a graph is drawn as long as the connections are the same. These two graphs, for example, look very different, but since we don't care about position or length, they're equivalent. All graphs that look different but are actually the same we call isomorphic. Many things, including islands and bridges, can be represented by groups of dots and lines we call graphs. Dots are vertices, lines are edges. The degree of a vertex is the number of edges attached to it. Graphs can be non-directional, directional, connected, or even isomorphic. And people like to spell their names weird. Thank you for watching and have a nice day. Be sure to check out the description where you can find challenge problems, other material, and also a directory for all my videos.